In today's video of the fundamentals of physics, we're going to break down a subtopic of physics known as kinematics. But before we do that, let's review what physics is. Physics is a scientific field of study in which scientists precisely define the most fundamental and measurable quantities in the universe, such as velocity, the electric field, and kinetic energy. Physics attempts to describe a complex universe with understandable laws. We will discuss some of these laws as we break down kinematics. So, what is kinematics? Kinematics is a branch of physics concerned with the motion of objects. These objects include everyday items such as your car, a roller coaster, and even your toy fidget spinner. But to understand basic kinematic concepts, let's take a look at the motion of a person first. A study of the motion of a person will involve the introduction of quantities that include distance, displacement, speed, velocity, and acceleration. Distance is a measurement that tells you how much ground an object has covered during its motion. Displacement refers to how far out of place an object is or its overall change in position. Consider the following example. A man walks from points A to B to C. To find the total distance he traveled, you would add up each numeric value of the interval between the traveled points. The total distance here would be 7 as you add 3 plus 2 plus 2. Now let's calculate the displacement. Displacement is the distance between the initial and final point of travel, in this case, points A and C respectively. The displacement in this example is 3 meters in the direction from A to C. A large displacement in a small amount of time means the object has a high velocity. Velocity is an object's change in position divided by the time of travel. And unlike speed, velocity is concerned with the direction of travel. The total distance in the previous example was 7 meters, and let's say the total time it took him to travel was 6 seconds. Then the velocity would be 7 over 6, which would be about 1.16 meters per second in whichever direction he was traveling. Now that we know the velocity, we can calculate his acceleration, assuming the velocity remained constant. To find acceleration, we would divide the velocity by the time interval, and in this case, you would divide 1.16 by 6 to get 0.194 meters per second squared as the acceleration. Now that we understand basic kinematic concepts, let's move on to slightly more challenging concepts using the loop of a roller coaster. On a roller coaster loop, the track applies a force on it towards the center of the circle, forcing it to travel in a curved path. This force is known as a centripetal force, and it makes the cart follow a circular path. Isaac Newton described it as a force by which bodies are drawn or impelled towards a point in the center. In order to calculate centripetal force, divide the square of the velocity by the radius of the circular path. To find centripetal acceleration, simply multiply this formula by the mass. Aside from roller coaster loops, the fidget spinner toy is another circular-shaped object that applies kinematic concepts. Fidget spinners use ball bearings comprised of small metal balls rolling in a circular path. Instead of spinning against each other, these balls spin between the rays to minimize friction. However, they aren't frictionless, which is why the fidget spinner eventually stops. Frictional forces always oppose motion and slow the rotation of the spinner. In order to increase the angular velocity of your spinner or make it go faster, you must exert a torque on the spinner. In physics, a torque is a force that tends to cause rotation. Keep Keeping your fidget spinner upright involves the law of conservation of angular momentum. This law suggests that an object's rotational velocity will stay constant until an unbalanced force acts on it. If the spinner is spinning on a flat surface instead of in your hand, the only force exerted on it is gravity, which is balanced, meaning the spinner will spin in the exact same direction without tilting. In this video, we discussed the basics of rotational kinematics, we learned about centripetal acceleration, and how to use basic kinematic formulas. I hope this video helped you understand the fundamentals of kinematics using fun, everyday examples. Subscribe for future videos on the fundamentals of physics.